Okay, this section is labeled 2-5, literal equations and formulas. A literal equation is an equation that involves two or more variables. So we're going to be solving ones for one of those variables that involves two or more variables. A formula is an equation that states a relationship among quantities. And I'm giving you a list of common formulas. We'll see some of these in our classwork and work with these. I'm just going to do a few examples that we'll use one of these on here and one that's kind of the same form. But you see the perimeter of a rectangle is 2L plus 2W. The area of a rectangle is A equals length times width. The area of a circle is A equals pi r squared. And temperature is C equals 5/9 times the quantity F minus 32. And the circumference of a circle is C equals 2 pi r. The area of a triangle is area equals 1/2 base times height. And the distance traveled is d equals rate times time. So if you want to pause the video and just go ahead and write those down, you'll be asking me to use those in the classwork. So we're going to do a few examples here. Right. This is called rewriting a literal equation. It says you're ordering pizzas and sandwiches and your budget is $80. If pizzas are $10 and sandwiches are $5, we can model a situation with the equation 10x plus 5y equals 80, where x is the number of pizzas and y is the number of sandwiches. How many sandwiches can you buy if you buy 3 pizzas and 6 pizzas? So, if we wanted to, if it was just asking, how many sandwiches can you buy if you buy 3 pizzas, we could just go directly to plugging in 3 for x and solving. As soon as I do that, I only have one variable. 10 times 3 is 30. And I can solve for this variable y, subtract 30 from each side. So we have 5y equals 50. And then divide by 5 on each side. So y equals 10. So it's saying if I buy 3 pizzas, I can only buy 10 sandwiches with my $80. Now, we really don't want to do that over and over again with different values of pizzas that we might buy. You can actually solve this equation once and for all for the number of sandwiches represented by y. Here's what I mean by that. Take this equation, 10x plus 5y equals 80, which we're later going to learn is called standard form of a linear equation. We're going to be doing lots of equations like this and solving them for y. So this is a two-stepper. It's a two-step process. Now, we have been writing underneath this what we want to get rid of on this left-hand side. If we're solving for y, we would want to get rid of the 10x, so we would subtract 10x from each side. Don't write this down yet. Just want to demonstrate something here. That would leave 5y by itself, but it implies that 80 minus 10x is something that we can do when we can. A lot of students will write, here's what I mean, 80 minus 10 is 70, they'll write that this is 70x. That's not true. The reason for that is those are not like terms. If 10, say, don't write this down yet, say 10 were 3, or x was 3, then what I'm saying is 80 minus 10 times 3 or 30 would be 50. If I'm going to say that 80 minus 10x is equal to 70x, then when I plug in 3 for x, I'm saying 70 times 3 is 210. I get completely different values when I plug those in if I treat them like terms. So here's what we're going to do. We are going to write it horizontally, right next to it. So 10x minus 10x plus 5y equals 80 minus 10x. If you want to write it vertically, you can. You just need to understand that you cannot combine these two terms over on the right. Now the 10x minus 5x does equal 0. That cancels out, leaving me just 5y equals 80 minus 10x. So that's the first step, is subtract 10x from each side. Sometimes we call it moving it over. Ends up moving over here, and we move it over, it ends up being a negative 10x. You should understand the reason why. Trying to cancel out the 10x on the left, make it cancel to equal 0. So that gives us a negative 10x that we're subtracting, or subtracting 10x from each side. Then we want to, second step is get y by itself. So we're going to divide each side by 5. Now, this is different than using the inverse operations of addition and subtraction. When I am dividing each side by 5 to get 1y on the left, I need to divide each and every term. A term is separated by a plus or minus sign, but divide each and every term by that number 5. 80 divided by 5 is 16. 10 divided by 5 is 2. Keep the negative sign. And there's my equation, y equals 16 minus 2x. So if I know the equation is y equals 16 minus 2x, I can now plug in, say, 6 pizzas to that. I get y equals 16 minus 12, or y equals 14 sandwiches. And now I have an equation with this one where I could plug it into a spreadsheet. I could have down the first column different values to plug in for x, like 1 pizza, 2 pizzas, 3, 4, 5, 6, all the way up to actually 8 pizzas. If I hit 8 pizzas now, I have 0 sandwiches, and then if I go to 9 pizzas, I'm going to be over my budget. But I could plug that in, and in the spreadsheet it would populate that column associated with this equation and give me the number of sandwiches I could buy with different values of pizzas. So that's the use of that, being able to solve an equation for a variable. All right, let's look at problem 2 here. It says rewriting a literal equation with only variables. Think back to flowcharts. Here we have, if you think about what's happening to x, it says x is being multiplied by the quantity a minus b. The inverse operation of multiplying by a minus b would be to divide by a minus b. So we are going to take this equation, divide it by a minus b. Whatever we do to one side, we need to do to the other. Now notice that a minus b divided by itself is 1, so x equals c over a minus b. So we have c over a minus b. That equation is now solved for x. Box it here. And then if you had values for c, a, or b, you can plug them in. Different values for c, a, and b would give you different values of x. All right. Problem 3. It says rewriting a geometric formula. So we're going to use one of the formulas from the front page here. It says, what is the radius of a circle with circumference 64 feet? Use 3.14 for pi. We'll do that with our calculator and round to the nearest 10. We can actually do better than 3.14. We can use the pi button on the calculator, so we'll do that. So I'm going to write down circumference formula for a circle. It's c equals 2 pi r. Okay. If c equals 2 pi r, then we want to solve for radius, we've got to think about, okay, what is happening to r here? What operation is going on here? We have them all written together. It's like this. We don't put the dot between them, but that's what it means. We're multiplying all those together. As a matter of fact, 2 and pi are being multiplied by r. So if we have 2 pi times r, the inverse operation of that would be to divide by 2 pi. So we take 2 pi times r, and we divide by 2 pi. Divide over here by 2 pi. The 2 pi's cancel out to equal 1, leaving us with r equals c over 2 pi. So that is the solution to the literal equation. We've solved r in terms of c. Now what we're going to do is replace c with 64. So 64 over 2 pi equals r. We go over to our calculator here and type in 64 divided by 2, and there's actually a pi button on yours. You hit second and then the pi button. Some calculators, the pi button may just look for the button up there. But instead of using 3.14 for pi, just use the pi button. And we get about 10.2 if you round to the nearest tenth. I think that's what it asked us to round to. Nearest, yep, 10.2. So the radius, r, equals 10.2 feet. So a circle with a circumference of 64 feet has a radius of 10.2 feet.